Hello, today we will review Keithley 2002 8.5 digit multimeter, and we will start with Teardown. This assembly is pretty similar to all other Keithley 2000 series devices, such as 2001, 2000, 2700, and so on. We just take out these two screws and one screw on the bottom. Nothing is better than breaking the calibration labels. So here we have digital board, pretty much similar to 2001 model, which I showed on EEVBlog forum before. The interesting part that the DC converter for the front panel is not populated on the digital board, but it's actually installed on the front panel. And the most of the crazy stuff is going on analog board in here. Let me get the camera closer. Okay, I'll be extra careful with all this analog stuff because this meter seems still in the calibration, so I don't want to mess up anything or put some dirt on the PCB, which can corrupt some precise measurements. So similar to 2001, this model have the protecting cover, which is from the both sides of the PCB, from the bottom and from the top, and we will take the top side out. This big boy filter, and ta-da! That's what we have here. According to the date codes, this meter pretty new. It's made in 2007, I think. So this is much newer than any of my Keithley gear in here, which I have already shown before. It's have couple 2001s and 2400s, like bird right in there. Okay, that's the mains input. It selects the 110 winding or 230, depends on the what country you are using it. And then we have true RMS converter and the filtering circuitry. Those big caps actually using for different frequencies. And over there we have DAC, 8-bit DAC, similar to Keithley 2001. Some inputs protection, read relays, then front or rear panel switch, more opto-isolation, read relays, and this is the current measurement, shunt resistor 0.1 ohm and 10 ppm 1%, and then CAT-dog network, which is actually using for different amps measurements and so on. Then we have isolation ICs to link together analog board and digital board. And this big green PCB is the ADC, together with the switch control circuitry and all that serial interfacing circuitry. And here we have Vishay hermetic resistors, which are using for the resistance. And there is another cat dog, which is actually consists of 2 resistors glued together, or even 3 resistors. And this is the board without the analog to digital converter PCB. So you can see a bunch of digital stuff and some op-amps. And then here we go, the voltage reference and the switching capacitor, multipliers and dividers. I'll take that cover from the voltage reference carefully, and then we take a look. What is it? Already based on this guy in here, we can presume that this is LTZ1000, the famous voltage reference from linear technology, which is one of the best Zener diode based voltage references available on the market. And carefully take this cover. And here it is, LTZ1000 ACH, manufacturer 2007, week 15. Also, as you can see, there are a lot of guard traces, which are those white traces around the pins. This is to prevent any leakage on the board between different components. For such sensitive meter, it's really critical, so they go above and beyond with all the guarding and protecting the critical signal path. And this is the ADC board. It's made by Keithley, and here is the code 2002-16204 revision B. It was developed in 1993 according to the date, and of course made in USA like all the high precision Keithley stuff. Here we have the control CPLD, which actually connects both worlds together, digital world and all the switching, communicating and converting the analog data from the comparators to digital form, which can be translated later for CPU. Here we have the main crystal, which is 12 MHz made by Fox, and then some op-amps and some passives around. From the top side, there is not much interesting stuff in here. So let's compare it to ADC unit from Keithley 2001, which is 7.5 digit meter. So I'll put these two boards together, zoom a little bit out. Even when these boards both using the same connector, they are not interchangeable, which is actually expected. They have different CPLD size. 2002 have much bigger package, which probably because they need more logic cells, more I/O to have use two references which are available on the Keithley 2002. 2001 have Altera or Cypress CPLD with 128 microcells, have more like through-hole components and such stuff. It was developed actually 2 years earlier than 2002, according to the date on the PCB. And since we already tear down 6000 USD multimeter, let's go for it and take a look which Altera actually they are using. Well, as expected, it is Altera branded, and Let's just take it out. It's Max EPM 7000 series with 160 macrocells, PLCC 84 package, laser coded 2002 800 2A01. Okay, let's put it back. Funny thing that chassis is actually share the same one from model 2001. Couple extra angles. Also here you can see the model number of the analog PCB is 2002 10204E E5. And the digital board is actually using PCB from model 2001. As you can see in here, it's 2001 14206 revision K. So the board is actually digital board shares the same design with model 2001. I actually happen to have exactly the same revision of revision K in one of my 2001 multimeters. It's actually was second meter which I bought, and it's hard to see, but you can see actually the same revision. This revision firmware is stored by two ROM chips, odd and even. Also, I was always wondering what is that socket for on model 2001 digital board. Seems like it's storing extra calibration constants and values which are used in 2002, because on 2002 let me get focus, sorry, here we go, 2 I2C Atmel 24C16s, exactly same locations, exactly same ICs. Here I removed Dallas chip, so we can update the meter from standard option to memory 2. But to do that we will need DS1245 IC, program it with specific firmware to allow Multimeter recognize extra memory. To update the firmware, actually I need to use the old programmer software. It doesn't work on Windows 7, so I have to use my scope just like an interface to program my IC. Let's flash. Run. Erase OK. Check OK. Programming. Verify. Oh, not OK. And now we change the jumper to memory 2 option. Install our Dallas NVRAM. Firmly nice. Let me check if it detects as memory 2. Okay, here we go. Memory 2 option. Oh, no clock installed. Let's see if main memory functions work. Okay, 10 profiles and store. The standard was maximum 404 readings, and memory 2 can go up to 5781. So let's store some stuff and try if it's okay. Here are our stored values, and power off and power back on. See if the stored values kept. Blah blah blah. Yep, they are there. So the memory 2 option works. So DS1245 just a memory, and probably they need memory together with the RTC clock inside. And if we look at the original chip, then it's actually have small IC, which is the RTC memory. Let's check that everything is working fine. I leave this message for now because I don't have the necessary Dallas ROM with RTC, so I'll buy that later. And let's run self-diagnostics. Have much more items than 2001. Okay, short high to amps. So enter. Insert 4-wire short. I use just my Kelvin Connect probe, shorted together. Okay, enter. Okay, all tests complete, no errors, no problems. And now let's actually measure the voltage reference. For that I'll use my calibrated 2001, which is right in there. So you can see the voltage in here. Okay, VGND and ref high. That's it, 7.134. Let me check basic accuracy. I have calibrated 2001, which is down below, and I adjusted my EDC MV106 DC voltage standard before. So, and also I have calibrated 2400 source meter. We'll check ohm accuracy and DC voltage accuracy. And speed 10 NPLC, filter advanced 100 readings, 1% of the range, resolution 8.5 digit, trigger, and this one I assume already set. Speed 10 NPLC. You actually may notice that resolution on 2001 is 8.5 digit too. I enabled that by sending GPIB command before. And I had the 100 millivolt voltage range. Let's set 10 volt. Okay. So that's what we got. Oops. I'd say pretty close. Let's down 2 volts and 3 volts. Okay, I need to change range. 4 volts. The last calibration, or let's say last test of this 2002 was in 2011 November, according to a label on the side. But in the menu it says the calibration date was last 2007, so I assume it was only went through factory calibration. 7 volts, 8, 9, 10. So that's pretty good. And again, this 2001 was calibrated about 3 weeks ago. Let's check current source accuracy. For that I'll use 2400 source meter because it's have far better current accuracy and ranges than 2001. So go range down and up. Well, actually 2002 says current source not available, but as we can see here, it's perfectly available, just not saying. Oops. I guess that's too low. Go higher. Go higher in voltage then. Actually, current is much lower. Had not enough voltage on the source meter, so it was capped by voltage. And bye bye.